Good afternoon, students. Good afternoon, students of the Vinci. Today we will be discussing the basic concepts of Arduino. Uh, it is regarding how we are going to create programs for the hardware, as well as learning basic programming concepts that we are going to use in order for us to formulate a program. So, to start off, uh, the program structure of Arduino comprises of three main parts, which is the structure, the values, and the functions. So let's start with the program structure. So program structure of Arduino Uno can be seen in the Arduino IDE. So Arduino IDE contains the setup function, which is this one, as well as the void function, which is, or the loop function, which is this one. So if you want your code to run um, during the runtime or when your Arduino Uno turns on, by the way, this is an Arduino Uno. Can buy one chip at Lazada for 150 pesos. So if you're looking to do your own live demonstration, or you want to use this for your hobbyist purposes, then you may buy so at any online store that you can find. So going back to our topic, void setup allows you to manipulate your code, or allows you to run your code once, especially during uh when you turn on your Arduino Uno. Meanwhile, if we put code here in loop, it will repeatedly run until your device is turned off. So, what are how do we use the different functions here? How do we use the setup? How do we use the loop? Uh, if we intend to use the code to run only once during the startup, then we put it on setup. For example, um, we want to make the bulb turn on permanently. Then we have to put it in void setup. If we want the code to make it do a series of tasks and repeat it over and over. For example, we want our lights to blink on and off repeatedly without any input or output from the user, then we put it in void loop. I will be demonstrating the use of this sketch tool on our next meeting. So let's move on. So now let's move on with uh, the data types. Data types are what most programming languages use to store and segregate data, regardless of where it came from. So from your previous MIL classes, we have discussed that uh, information is uh, information is data. Information is data that has been processed uh, has been processed. So now we are currently going to receive data and going to process it into different forms in order for it to be usable to us. So one way of processing the data is by assigning data according to its category, and that is data types. So data types refer to an extensive system for declaring variables and functions of different types. So these are some of the examples of data types that are being used in Arduino. So let me exhibit some here. Let me exhibit the usage of some. Let's use the void setup just for our demonstration purposes. we have the most common ones. I will be categorizing this depending on their usage. So we have Boolean, which is bool. We have car or character. We have the byte, the integer or the int, the long, the short. Then we have float and double. Then we have string. So let's start with bool. Bool or Boolean is a data type that can only store two types of data. It could either be true or false. If you're familiar with truth tables, then that is the Boolean principle. So, Boolean can only store one bit of data, which is either 0 or 1, represented by true or false. 0 meaning false, 1 meaning true. So, how do we declare a Boolean data type and assign a value to it? So, let's say bool. So, to declare a data type or to declare a variable, we must start with uh, the data type. So, the data type is bool. Then, next one would be the variable name. For example, we're going to name it um, uh, will let's say, or let's remove the question mark. I created a variable named will 2021 be fun? Then assign a value of, let's say, true. So this is how we use the Boolean data type. So if we interpret this in English language, um, I created a Boolean data type with the name of will 2021 be fun and assign it a value of true. So I didn't put here equals because this is not the what we are accustomed to. Kasi 'di ba we are already accustomed in mathematics that equal sign is equals. But it is not so in programming. In programming, we call this assignment operator. I will be uh, orienting you what assignment is. So let's just say the equal sign here should be the word assign, not equals, assign. So let's just say assign it a value of true. The next one is the character. Character can store a single character from the keyboard or any ASCII character that is currently out there. So it can store a single letter, number, or symbol that you may perceive of. For example, character, my first letter. Then let's put in this. So that's how you assign. So in English, it should be I created character data type with a name of my first letter and assign it a value of k. Next one are what we refer to as integer data types. Integer data types are uh, the most simplest number variables or number data types that we can think of. They are capable of storing whole numbers. They are capable of storing whole numbers, but they only differ in range. For example, the smallest range among these data types are the byte. Byte can only store 8 bits of information. Meanwhile, uh, int can wait. Um, int can store 32. Long can store 64, and short can store 16. So I'm going to explain to you what these bits are, because I'm sure you might have heard this just this time lang. You're not really acquainted with how this works. So let's go back to our analogy from our first lesson. Um, in my first lesson, I've discussed that programming or the computer only understands uh, the language we call as binary or binary numerical system. This is the most basic programming language the computer has. It is basically on and off for them. In our mathematical in our math, we humans usually use what we call as decimal numerical system, right? We do our operations from 0 to 9 before we move on to other digits. That's how we perceive our math before the next digit. But for binary numerical system, 0 to 1 before the next digit. Binary meaning two digits or two numbers. Meanwhile, decimal means 10 numbers. And those numbers are 0 to 9. So how does this differ? How does this relate to 8 bits or 1 byte? So let's say, because binary only has 0 or 1, let's just say 1, 2, 3, 4, 5, 6, 7, 8. Each one here represents a bit of information. Let's say this one. This represents 1 bit of information. Now, um, for us, we normally use 1, 2, 3, 4, 5, 6, 7, 8, like that, right? We usually use this. Or let's say 1 million or 100,000. Each digit represents 10 numbers. So let's say this one is 1, or let's say 10 to the power of 0, which is 1. Then 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, 10 to the power of 5. But it is different for binary. So let's say this first digit is 10 or 2, because it only involves two numbers. 2 to the power of 0. 2 to the power of 0, any number with the power of 0 is always 1. 2 to the power of 1. Then 2 to the power of 2, or 2 times 2, 4. 2 to the power of 3, 8. Then so on and so forth. Meaning, each digit represents a number value. Depending on the combination of these numbers, you can create a number. Let's say 1001, 1001. It means that it has a value of 1, 8, 16, and 128. You add them all, then you will come up with a number of, let's say, calculator. This is how mathematical operations work in a computer. So 1 plus 8, or 1 plus 8 plus 16 plus 128. Meaning, 1001 means 153 in our decimal numerical system. So, if we want to find out the range of the numbers here for the byte, again, it only stores one bit of information. It can never have two here because one is the maximum number. Let's say every number is turned 1. You will find that it is the maximum range of the number. So let's say every number is turned on. It means 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. So let's just add that. 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. So the value of the maximum range of the value of 8 bits of information is 255. Meaning a byte can have a range of negative 255 to 255. Now, for int, it means that there is 32 segments of ones. So, most of the time, people use int to create mathematical operations inside Arduino and most programming languages in general. Because the range here is uh, the limit is around 32,000 numbers. So let's say here, for example, to simplify this, this is the range. Because this is a 16-bit number, I overshot the number here. 16, then 32. So because the range is 16-bit, meaning it has a range of negative 32,768 to 32,767. Then for long, where's the long here? Long here, because it has 32 bits of data, it can store as much as 2,147,483,648. So it can store up to 2.1 billion. Then the short, which is only up to 32,000 or 16-bit. But usually we don't use short in our programming lesson. So let's just ignore short for now because int and short are almost the same. Now let's move on to what we call floating point numbers. You might be worried, but sir, how are we going to store decimal point values or decimal points? Because you said that integer can only store whole numbers. What if we have a number such as, let's say, pi, which is 3.141591? So the answer would be using either float or double. Float or double are numbers or floating point numbers which are capable of storing uh values that are commonly referred to as decimal point numbers. For example, another is gravity. Let's just say 9.18 or 9.81. So we use floating point numbers in order for us to create decimal points. The difference between float and double is that float is single precision floating point number. Meanwhile, double, the difference between this is that double is much more precise and accurate in storing these values. Meaning that whenever uh, a floating point value is cut off, it will uh, be able to adjust its value correctly and accurately. So, lastly, we have string. String is a character array, meaning it can store, uh, for example, I want to store my name. So, it is capable of storing uh, long strings of characters. So, that is the purpose of strings. Now we are moving on because I think we have discussed most of the data types. Now let's discuss the two categories of data types, which are the variable and the constants. So variables means that a data can change at any moment within the program. For example, we are going to assign or we are going to create a variable x and assign it the value of 12, or then we are going to create an integer variable and of y, assign it the value of 15. Then we are going to create another variable, lastly z. We're going to assign it the value of 10. Now let's do an addition operation. Let's say the value of z will be the addition operation between x and y, meaning z the z will have a new value, and its new value will be x plus y, or 12 plus 15. Now the value of z should be 27. Its value is not 10 anymore. So we call these kinds of data variable, meaning ever changing. In contrast, we have something we call constant, meaning that the value will never change once assigned into the program. In nature, we all have constants. For example, the gravity at sea level, it should be 9.81. At sea level, the gravity should be 9.81. And the pi should never change. It should never become 5.14 because it will always be at this value, right? Pi should never change, meaning they are what we call constants. This should never change. So that is the difference between variable and constants. Now let's move on to operators. I've already told you earlier about the symbol equals, right? Because it directly conflicts with how we use math in our daily lives. We are already accustomed in our brain that equals symbol should be equals. But now you are being challenged with the notion that the equal symbol should have the meaning as sign. And this is because of operators. Now, we will be discussing about operators. In simple definition, operators are what causes the data to change. Again, operators are what causes the data to change. For example here, originally, x doesn't have a value until we assigned it the value of 12. So the operator here is this equal symbol. We assigned it the value of 12. So from no value x, we change it to 12. So that's how operators work. So there are multiple kinds of operators. So there are arithmetic operators, comparison operators, Boolean operators, bitwise operators, and compound operators. So let's start off with arithmetic operators. So let me erase everything here. We are already familiar with four of the operators. We have the plus sign, which is an addition operator. We have the minus sign, which is a subtraction operator. We have the asterisk, not the x, because x is used as a symbol. So let's avoid using that and use percent sign or asterisk as the multiplication symbol or multiplication operator. Then lastly, we have the slash as the division operator. Now, we already know all of these four, but in programming, they have added another operator to this. And the operator is called modulo operator. Sir, we are already familiar with the maths with addition, subtraction, multiplication, and division. How does modulo work? So, for example, here we already created z is equals to x plus y, right? Already created z equals x plus y. So, this is an addition operation. So, let's say we are creating another set of integers. Let's call this integer a. Let's put this a value of 3. Integer b. Let's put this a value of 5. Integer c. Let's put this a value of, let's say, 4. And integer c, d. Let's put this a value of 0. So we have two or four variables here. Or we have four variables. The A, B, C, and D. So if we assign a value and store it to letter D or integer D, let's say A plus B plus C, meaning we are going to add 3 plus 5 plus 4 and store it to C or store it to D, right? But how does modulo work? Let's say 5 divided by 3. What do you think will be the value of D? The value of D should have, or let's just say A. D should have a value of 1 because 5 divided by 3 is 1. Sir, shouldn't it be 1.5 or something like that? Again, I have told you earlier that integer doesn't accept decimal points. It only stores the whole number. So it will ignore any decimal points. So regardless, D should have a value of 1 because 5 divided by 3 is 1. Now, let's say 5 D or D again have should this have this operation B modulo A. D should now have a value of 2. Sir, I'm getting confused. So let's go back to our first operation. D should have a value of 1 because again, 5 divided by 3 is 1. But 5 modulo 3 is 2 because modulo operator is the remainder of a division operation. Meaning, 5 divided by 3 ay 3 5 divided by 3 remainder 2, meaning modulo is 2. Whatever the remainder of a division operation is, modulo will be able to accept that. So that's how modulo works. Now, to be acquainted with other operators. Comparison operators and Boolean operators. Both are being used to create logical or truth tables, logical or conditional operators or operations. So, logical or conditional operations are what we use to actually make the program decide if it is going to proceed to this or to this. Difference in the program flow. It aims to create a different uh, flow for the program. Um, in your first year in or in your grade 11, you have already learned about truth tables. Then you will be encountering more about truth tables. You will be encountering more about truth tables here. So again, uh, we are already familiar with and, or, and not, right? We're already familiar with it. If used in conjunction with equal, not equal to, less than, greater than, or relational operators like this, then you are able to create a sensible program. Now, let's move on to compound operators or what we call compound assignment operators. So, just a quick assignment. Wait lang. Let me assign. There. I think it should work out for you. So now, let's go back to the assignment operator that we have discussed earlier. Compound operators or compound assignment operators are unary operators. Compound operators are unary operators or operators that work with one operand. So, sir, I'm getting confused with what you're saying right now. So, let's go back to our addition operation earlier. This is an addition operation, right? So, this is the addition operator. And this is the assignment operator. So, addition operator is what would, or these kinds of operators are what we would call as binary operators or operators that work with two or more operands. Sir, what are operands? In your elementary years, you are being taught that there are addends, the sum, right? There's sum, there are quotient, there are dividends, multiplicants. I got confused. Kindly turn off the microphone. Okay, so there are different types of operators, right? So x and y, x and x, y, and z should be operands. Or what is being manipulated by the operators? X, y, and z should be the operands, while plus and equal symbol should be operators. So the first operation that is happening here is this. Arithmetic operators are binary operators because it requires two operands, the x and the y. So this is the operator. So x is and y is being manipulated by the operator plus. While the second operation happens here. So now the equal symbol is manipulating the operand z. These are two separate operations. So the first operation is x plus y. And the next operation is z assigned to the value of x plus y. So that is the second operation. So there are two concurrent operations here. So again, going back, compound operators are unary operators. It means that it only requires a single operand. For example, the equal symbol, right? It only requires a single operand, which is z, then assigning a value to it. Meaning, you can function without the accompaniment of the other operators. Next, we have increment. Increment adds a value of 1 to the current value. Let's say z is equals to 12. It means the value now becomes 13 because the increment adds only by 1. It adds an value of 1. Meanwhile, we also have decrement. Decreases a value of 1 to the current value. The value becomes 12 again. Then we have compound addition, which is z plus equals to, let's say, 3. This works similarly like this. Z is equals to z plus 3. Meaning, uh, it adds a value of 3 to the current value. The value becomes 15. Now we have compound subtraction. Compound subtraction. Let's say z minus equals to 3 again. So z is equals to similar to z minus 3. Decreases the value of 3 to the current value. Now this becomes back to 12. Then we can do the similar operations that can be found here, which is just similar to how this works. Now, about the control statements, I think we cannot compress this in a single class. So I would like to thank you for your participation today. Do you have any